Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 6. I am a road engineer and asked to design a curved ramp as part of a highway, which will be banked at an angle of 8 degrees and will have a radius of 220 meters. If an ordinary 1000 kilogram car is to negotiate the curve safely at 130 kilometers per hour without skidding, what should be the minimum static friction coefficient between the road and tires? Here the speed of the car is given as in the units of kilometers per hour, which is a non-SI unit, and it is converted into meters per second by the following procedure. Now we can solve the problem. First of all, we draw the free body diagram of the car. As a first step, we choose the appropriate coordinate axis. Next, we draw all the forces acting on the object. There is a gravitational force on the body like this. Secondly, since the car is in contact with the surface, there is a normal force perpendicular to the surface like this. Finally, since the car moves without skidding, there occurs static frictional force between the tires and the surface like this. Now it is convenient to decompose N and Fs onto the X and Y axis like this. As a final step, since this is an example of uniform circular motion, the acceleration vector along the x-axis is drawn like this, which is the centripetal acceleration of the motion. Okay, that's all about the free body diagram of the car. Now, we write the equations of motion by the help of the Newton's second law, F net equals ma. In order to write the equation of motion along the x-axis, which represents the centripetal motion, we choose the direction of the acceleration vector to be positive. Therefore, the net force becomes n times sine theta plus fs times cosine theta, which is equal to m times ar, where ar is the radial acceleration, that is centripetal acceleration, with the formula v squared over r. Next, since there is no motion along the y-axis, the acceleration of the body is 0. Then the equation of motion along the y-axis becomes n times cosine theta minus fs times sine theta equals m times g. So, to eliminate the second terms on the left-hand side, we multiply equation 1 by sine theta, equation 2 by cosine theta, and add them side by side. We obtain, on the left-hand side, the term fs times sine theta times cosine theta is gone, so we are remained with n times sine theta squared plus cosine theta squared. Here we know that sine theta squared plus cosine theta squared is equal to 1. As a result, we obtain an expression for the normal force N as, with the numerical values, we obtain the normal force N as 10,530 newtons. After that, Using equation 2, we have Fs equals n times cosine theta minus m times g over sine theta. Now we put the corresponding numerical values into this equation. Then we obtain 4,508.9 newtons. Now, using the relationship between the frictional force and the normal force, we obtain an expression for the static friction coefficient as Fs over n. With the numerical values, we get approximately 0.428, which is a unitless quantity. Okay, the result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.